For this video, I'm going to talk about how to facilitate the warm-up for Lesson 5B, How Many Solutions? The focus question of this lesson is how do graphs help us determine when a quadratic equation has two solutions, one solution, or no solution? So if we jump into the warm-up on here, the warm-up is designed as a single slide that students respond to, and this would be if they were working asynchronously. If you are in a synchronous lesson, you can facilitate it a little bit differently. And I'm going to show you one example using Jamboard. So here are some quick directions around this warm-up for facilitation and things to keep in mind. So this warm-up reminds students of two facts. In order to use the zero product property, the product of the factors must be zero, which is super important for this lesson and future lessons and to eliminate misconceptions. And then also there is no number that can be squared to get a negative number. Also really important for student understanding. So at this point, students don't yet know about complex numbers, that squaring a complex number produces a negative number. So you might be saying, well, there is a number that can be squared to get a negative, but we're not going to be talking about complex numbers. So we're just going to say there's not for now to just prevent any confusion from happening. Okay. And while doing this exercise, because we are going to ask students to explain when we do this live and synchronously through this Jamboard example. And so we want to give students an opportunity to do this because it allows them to practice constructing logical arguments, which connects to MP3 standard. Okay. So the directions for this is you're going to display one problem at a time as opposed to giving it to all of them. And you can share with them the link to this Jamboard and just instruct them to stay on one slide. And what you can do is just give them some quiet think time for each problem and then ask them to give a signal when they have an answer and an explanation. And keep all problems displayed throughout the talk and then follow with a whole class discussion. And all of these directions are pulled from the Illustrative Mathematics lesson plan that corresponds with this lesson. That you can find linked at the beginning right here. If you click this, you can get a link that will kind of give most of this guidance to you. So here's a way that you could gather responses. You can also use the Zoom features, the agree, disagree on Zoom. I think there's like a green check and a red X. There's also thumbs up and thumbs down. But one option to collect responses is just ask them, put a check on the side you agree with. Is it true? 3 is the only solution to x squared minus 9 equals 0, or is it false? They can just do a check like that. And this will be a way, the nice thing about this is it gives access to all students, especially students who might be shy. And then you can kind of count how many checks you have, and it gives you a chance to say, well, I have 7 responses, 10 responses, waiting on a couple more. And then not sure gives students who aren't sure still a space to be held accountable for sharing their response. Okay, so when you go over this question, you give them some think time, allow them to put their check off, and then give them some time to prepare an explanation. And then you might cold call on someone. You might ask for a volunteer, depending on how you structure your class. You might even ask students to give a thumbs up if they have an explanation ready and just pick someone from that group. And so somebody might say false, all right? And they might say false because there are two solutions, because there are two numbers that can be squared to get 9, right? What are the numbers? 3 and -3. Okay. So you might ask, who could restate this person's reasoning in another way? Did anyone have the same strategy but would explain it differently? I saw some falses. Does anyone disagree? Why? And you can facilitate the conversation that way, making sure students understand the rationale that makes each statement true or false. That's the goal of this. So we want them to understand why this statement is false. Next, we can give them this one. A solution to x squared plus 25 equals 0 is -5. True or false? Allow them to check it off. Give them the think time. Ask for somebody's justification. And we would be able to say there is no solution because no number can be squared to get -25, right? People are probably going to say true here. They're going to say -5 squared equals 25. Why does someone disagree? Does anyone want to add on? Did somebody solve it in a different way? Give students the space to answer this question and give their explanation. Somebody who chose false, why did you choose false? Why did you choose true? And you should see students start to guide each other to the understanding that this is actually false. Because it doesn't say x squared equals 25, it says x squared plus 25 equals 0. And we know the only number that can add to 25 to make 0 is negative 25. And there's no number we can square to get negative 25, which takes us back to that key understanding from the beginning. And you can even tell students if they want to change their response as they go, they can erase their check mark and put it somewhere else. They can change the colors of their check marks if they want to, have something unique about it. Next one, x times the quantity of x minus 7 equals 0 has two solutions. Give them think time. You want students to end up saying true. There are two factors, 0 and 7, that can make the product 0. This is the zero product property. Any number times 0 will equal 0. And again, asking those questions. Who can restate this person's reasoning in a different way? Does anyone have the same strategy but would explain it differently? Did anyone solve this in a different way? Does anyone disagree? Does anyone want to add on, right? So giving them those prompts to go ahead and have that conversation. And again, giving them opportunity to move their check to another part. The who can restate so-and-so's reasoning is a really good low-level question to ask students who maybe wouldn't be the person that would feel comfortable answering first and taking that risk, but might be okay just sharing that, and allows them to get involved in the conversation. Also gives you a way to check for understanding if they understand what's happening in class. And also reinforces for everyone else what that person just said. So it's a good one. And we have a tendency to restate ourselves someone else's reasoning, but put that in the space of the students. And then 5 and 5. So the slide said 5 and 7, but I think negative 7 is a better one to put here, just because it kind of touches on the zero product property, but noticing that this isn't 0. So I changed this to a negative 7. 5 and negative 7 are the solutions to x minus 5, that quantity of x minus 5 times the quantity of x plus 7. Okay, again, think time. A lot of students are probably going to say true because we're used to just saying, oh, zero product property. But what do you notice here? That's a 12. Why is it false? I substituted them in. I realized it doesn't actually work. It would make it 0. It wouldn't make it 12. Oh, okay. We can't use the zero product property here. So again, asking those questions to facilitate a deeper understanding, and then allowing students to really draw those two conclusions that we said at the beginning, right? Coming back to this always. In order to use the zero product property, the product of the factors must be 0. So you might even ask after that question, so when can we use the zero product property? How do we know we can use the zero product property to solve an equation? The products of the factors have to be 0. There is no number that can be squared to get a negative number, right? And that is really reinforced here. There is no number that can be squared that will give us negative 25. So what do we know about squaring a number? It will always produce a positive number, okay? And so in summary, this is just one option for you to use to facilitate this warm-up conversation, but it is a really rich discussion that can be had to close the gaps and some misconceptions and get students set up for success within this lesson.